Hi, welcome to my video on the area of a triangle using two sides and an included angle. Area of a triangle with two sides and an included angle. Well, here's a triangle that has two sides, A and B, and the angle in between those sides is theta. So to find a formula for that, we'll drop a perpendicular from here down to here. We'll call this the base. So we call this the height of the triangle. So now we have, I'm going to use SOHCAHTOA, and that gives me the relationship. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So we're going to use sine is opposite over hypotenuse. So take this angle here, in this right triangle, we have the sine of theta, which is the angle, is opposite, which is h, over a. Put it over 1 and cross multiply. 1 times h is h, and we get a sine theta. Now the area of a triangle normally is a half the base times the height, if you have a height. But notice right now, in this triangle we have a and b and theta. So we can't get the area of this triangle because we don't have a height. But by dropping the perpendicular, we now have the height in terms of the hypotenuse, or this side, and the angle. So the base, the height is replaced with a sine theta. So the area of a triangle is a half of a b sine theta. And as you can see, the original diagram is a half of the two sides and the included angle. We can find the area of a triangle. So that means we don't need the base. We have two sides and an included angle, then we can get the area of the triangle. And to illustrate that, I have state the area of each using two sides and included angle. Well, the area of a triangle is a half of AB sine theta. So if we take the only angle that we have here, because these are marked as the sides, F is the only angle. So we got the sine of F. So if F is the angle, the two sides that make up this angle are C and G. So a half of C times C and D. So a half of C times D sine F. And in this one, again, the area of a triangle is a half the base, half of AB. B don't have to be the base, sine theta. So this is the two sides. So again, I have a half. This is the angle we're looking at. So it's the sine of beta. And the two angles, the two sides that make up this angle are x and y. And in C, again, the triangle is a half of A times B sine of theta, the included angle. And the angle we have is C. So the two sides that make up angle C are A and B. So the area of a triangle can be found by two sides and included angle. Okay, let's work out some problems related to that. And here we go. We have the area of a triangle is a half of AB sine theta. So we're going to find the area of each to the nearest tenth of a square meter, and all units are in meter. So we have a half of 8, B is 6, and the sine of 39. So a half of 8 is 4, so 4 6s are 24, sine 39. So let's work that out using the calculator. So again, half of 8 is 4, 4 6s are 24, sine 39. And that gives me 15.1 to the nearest tenth. So 15.1 1, and it's in meters, so it's square meters. Number 2, we have two sides and included angle. So the area of a triangle is a half of AB sine theta. That's a half, and one side is 12.7. The other side is 18.1, and the sine of the included angle is 110. So I'm going to punch all that in the calculator. So clear that. So it's a half is 0.5 times 12.7 times 18.1 times sine of 110, and we have 108 to the nearest tenth, and again is in meters, so square meters. And we have another one, but this one's a little bit different. So we have these two sides, which are 12, 12, and 7. So I need this angle. If this angle is 150 degrees, there's 180 degrees here, so that means that that angle is 30. So if that angle is 30, 20 and 30 is 50. So a triangle got 180 degrees. That's already 50 here. So we take off the 50. We'll get 130 degrees for this angle. And there's another way to get this angle too, because this is the exterior angle of this triangle. And the exterior angle is equal to the sum of the two non-adjacent interior angles. So 20 plus what makes 150 is 130 is another way. Now, so the area of a triangle is a half AB sine theta, which is the included angle, so it's a half of 7 times 12 sine of 130 degrees. And to work that out, we could take a half of 12 makes 6, so we got 42. So I'm going to go 42 sine 130. So 42 sine of 130 gives me 32.17. So it's 32.2. So 32.2. And again is meters squared. So that's working on some problem. Now, on the next page, I have some more. So what you can do if you want to pause your video and work any of these out before I do, go ahead. Find the exact area this time. The exact area means we don't want decimals. We got to have pi, we got to have roots, we got to have irrational numbers. But we want to do it two different ways. So how are we going to do this with two different ways? Well, notice one way. Let's do it. I noticed that there's 8, 8, and 8. Since all sides are equal, that means all angles are equal. So a triangle adds up to 180 degrees and they're all equal. That means each angle must be 60. So 60, 60, 60. Now I can get the area using the half of AB sine theta, because I have two sides and included angle. Two sides and included angle. So it's a half of 8 times 8 sine of 60. And let's work out the sine of 60 first. So in the special right triangles that we dealt with in trig, remember we have what? We have a 30 and a 60. If this hypotenuse is 1, opposite 30 is a half, opposite 60 is root 3 over 2. So the sine of 60 is opposite over hypotenuse, so it's a root 3 over 2. Opposite over 1, so it's root 3 over 2, sine of 60. So now we have all these to multiply. So 2 and 8 goes 4. This 2 cancels the 8, 4. So we get 4 times 4 is 16 root 3. And the units in meters, so again we have square meters. So notice we have an exact value. Okay, now we said we're going to do this one another way. So let's redraw the diagram down here and do it by method B. So we have an 8, an 8, and an 8. So what we showed you before in the previous units, if two sides of a triangle are equal, we can draw a perpendicular from the top angle down to here perpendicular, and as a result these two triangles will be congruent, because what happens, this is equal, these two sides are equal, this side is common, and this is a right angle, so these two triangles are congruent by what we call the HL, hypotenuse leg. Since the two triangles are congruent, that means that these angles are congruent here, and these angles are congruent by ITT. So what we have, we know we have a 60, and we have a 60, and because that's a 90 and a 30, this is a 60. Because these triangles are congruent, that makes this angle 30, and this angle has 30. So if you think about it, I'm going to redraw the diagram now. So I have a 30 and a 60. So we have a special right triangle another way, in that if this side is n, this side is 2n, this side is n root 3. So that means if this is 8, that means because there's a perpendicular drawn down here, that's a 4, and that's going to be a 4. But if you redraw your diagram like this, you have a 30 and a 60 here. If this side is 8, that means that if you compare the two triangles, which are now identical, that means that 2n is equal to 8, and to divide by 2, it means n is equal to 4. So n is 4, this is 4, and this one is 4 root 3. So we got a 4 here, so this side is 4 root 3. And also remember that because it's perpendicular and these two sides are equal, it bisects the base, making it 4 and 4. So Pythagorean, you could work this out to get this 4 root 3. But now the area of a triangle is half the base times the height, because the base is 8 and worked out to be height to be 4 root 3 using, again, notice the difference between this triangle where you have 1, this is a unit triangle and a unit circle. Remember we draw the circle and we put this point here is 1, 0, and the radius of the circle is 1. So when we draw this triangle like this radius is 1, and because this is a 60, this is root 3 over 2, and this is 1/2. But here we're, excuse me, just doubling up the triangle, a little bit different. It's n, 2n, and n root 3. So a half of 8 is 4, so 4 times 4 is 16 root 3. So I did it two different ways. Did it with the two sides and the included angle to get the area, or I did it by using the special right triangle of n, 2n, and n root 3. Okay, number 5, find the area, and it says exact area. So the area is a half of AB sine of theta, the included angle. So that's a half of 11 times 8, the sine of 135, and we want exact. We don't want to use a calculator, because if you use a calculator, let me use a calculator for a second. If I turn it on, clear it, the sine of 135 is, notice keeps on going. It's non-terminating, so the sine of 135 is going to be an irrational number. So let's move the calculator. So what about the sine of 135? Well, let's draw a figure here, and let's draw a circle. And we do a rotation on the circle 1, 0, right over to here. There's 90. 135 is the rotation right to there. So when we draw that triangle, do that rotation like this, drop a perpendicular. That's 135 degrees here. That means this arc is 45, so this central angle is 45. So this is a 45. So if the hypotenuse is 1, opposite 45 is root 2 over 2. It's a special right triangle. Opposite 45 is root 2 over 2. The y is positive and the x is negative. So the sine is the y. So we have a half, 11, 8. And the sine of 135 is the same as the y value, which is root 2 over 2. So now we multiply, and we have a half of 8 is 4, and 2 divided by into 4 is 2. So we have 22 root 2 when we work that out exactly. And we got meters squared. Again, that's, as you can see, a half of 8 is 4, 2 into 4 is 2, 11 times 2 is 22 root 2. Exact value. Not a calculator job, because we have to change it to root 2 over 2. Now, number 6. Pause the video and see if you can work it out. This time, it says find x. X is the length of the side, and we're given this triangle. Notice we have two sides and an included angle. And the area is 81.7. So the area is a half of AB sine of the included angle. The area is 81.7. Half. A is, you could say 16. B is x. And the sine of 74 degrees. So 81.7. And so what we have, put the calculator here and clear it. So we have a half of 16 sine 72. So that's 8 sine 72. So 8 sine of 72 degrees. That works out to be 7.6. 7.6x. So the x is the unknown here, so I'm going to simplify this side by multiplying. Now I'll divide by 7.6. So that cancels. So now I have 81.7 divided by, let's see, 81.7 division 7.6. And I have 10.75, which is roughly 10.8 to the nearest tenth. So it's 10.8. And it's in meters. Because the area is in square meters, that means the length is in meters. So notice this time we're working backwards here. Now, number 7, see if you can work this one out. Find the exact value of x. Notice the area is 18 root 3, and we have two sides and an included angle. So the area is a half of AB sine theta, which is the included angle. So the area is 18 root 3, half. One side is 8, the other side is x, and we're working out the sine of 60 degrees. So 18 root 3. Now I'm just going to work out the sine of 60. Well, remember, we drew a circle, and we had rotation of 60 degrees is right here, perpendicular. So this is a 60. This is a 1 on the unit circle, 1, 0. Radius is 1. So that's a 60. This is root 3 over 2. This side is a half. Sine is the y, which is root 3 over 2. And if you check your calculator with the sine of 60, sine of 60 is 0.866, which is root 3 over 2. So we got 18 root 3 equals, now we simplify this, 2 into 8 goes 4, 2 into 4 goes 2. So we have 2x root 3, so it's 2 root 3x. And divide by 2 root 3 on each side. And that cancels, so x comes out to be 9. Perfect. Notice we're talking about exact values, so the sine of 60. If you did the sine of 60, just put the calculator here, clear that. If you did the sine of 60 on your calculator gives you 0.866, which is an irrational number. So we have to go with the special triangles to get the root 3 over 2. Okay, let's continue. More practice. Number 8. Find theta as an acute angle to the nearest degree. So we have two sides and an included angle. But the area is 6 inches. Okay. So the area is a half of AB sine theta. Oh, just happen to notice, go back to here. The area is square centimeters, so this is 9 centimeters for the length of the side. Just forgot to put that in. Okay, let's continue. Now we have the area is automatically given to us. The area is given to us as 6 half of 6 4 sine theta. So now we're looking as find theta, we're looking for the angle this time. So the area is 6, we put it in. 6 and 4 are the sides, so we work out half of 6 is 3, so that's 12 sine theta. And we divide by 12, we get 1/2 equals sine theta. And so that means theta equals sine to the -1 of 1/2. So if you use your calculator, which I'm going to, just to see, here we go, I'm going to clear it now. So we got sine, inverse sine of 1/2, which is 0.5. And the calculator comes up with a 30-degree angle. Perfect. That's the acute angle that we want. But if you think about it, also, if you think about the special right triangle, remember the special right triangle is 1, and we had 1/2, and as a result, this is root 3/2. So in this special right triangle, this angle is 30, and this angle is 60, because opposite 30 is 1/2, opposite 60 is root 3/2. And the sine of what angle gives you 1/2? Well, the answer is the sine of 30 is the opposite over hypotenuse. This is 1/2 over 1. So 30 is the angle. So I worked out 30 with the calculator, or worked out 30 knowing the triangle. Okay, let's try another one. Don't forget to pause the video. Find theta as an obtuse angle. So very similar. I got two sides, an included angle. I got the area. So the area is 1/2 AB sine theta. Area is 5.3. Half. A is 3. B is 15. And sine theta. So 5.3. And that's 45 times 1/2. So that's 22.5 sine theta. And divide by 22.5 on each side. Cancels out. So sine theta. So 5.3. Let's put the calculator there. So clear that. So it's 5.3 division 22.5 gives me 23555. 23555. So it's 0.2356. So now I get theta is sine to the -1 on that number, 0.2356. So theta comes out to be. And in our calculator, now I have that number there, so I don't know if you're familiar with it. There's my number. So I don't have to declare that number. So I'm going to do what this calculator says. I'm going to do the sine to the -1. Watch. I'm going to show you two. So if I do inverse sine, I can type that number in, or I can do this, second function, answer. Answer is here. So that puts the answer that I have in the calculator without typing it in. So I get a 13.62. So that's to the nearest degree, so that's 14 degrees. But what I want to do is just explain that again, just to make sure. So what I did, I went inverse, and that's, I can't do it that way now because I got a different answer there. So if I go inverse sine on decimal 2356, decimal 2356, I should get same. Notice this time I typed it in, but before I didn't. I just went second function on the answer, and the answer went in without typing it in. So just be careful with your calculator. Check it out. So 14 degrees. Now that's an acute angle. So let's explain. Let's explain. Remember, we have add sugar to coffee. Notice the sign is positive. Sign is positive in quadrant 1 and in quadrant 2. So in quadrant 1, this answer would have been 14 degrees. But the same reference angle is in quadrant 2, so that reference angle is 14 degrees. So in the second quadrant, which is 14 degree reference, theta is 180 minus the 14 degrees. So theta is 166. So the answer is theta is 14 or 166, but the answer to the problem, we want an obtuse angle, so the answer is 166. 14 will do it too, but they don't want the acute angle, they want the obtuse angle. So there's two angles that will do this in the rotation from 0 to 360, but we don't want the 14. But the 14 is needed to help to get the answer of 166. Okay, another one to do. Again, this one, it's very important to follow what I'm using here. So we have two sides, 7 and 8, and an included angle with the area again. So same formula. Area is a half of AB sine theta, and the area is 26.9. Half of A is 7, B is 8, and again we're looking for sine theta. So we got 26.9. So this is a half of 8 is 4, so half of 8 is 4. So we have 28 sine theta. So we'll divide both sides by 28. Notice I didn't move sine, switch this around, just let it stay. It's easier just to let it stay. And keep sine theta on the right side. So now I got 26.9. So use my calculator. Make sure you can see it. So I have 26.9 division 28. And that gives me decimal 9607. And so theta is sine to the negative 1 on 0.9607. And so there's the answer that I have here. So without clearing it, I'm going to go inverse sine on my answer that I had there just then. And it should give me 73.89. So that's close to 74 degrees. But I want to go back to that again, show you the 74. So if you did clear it, if you went inverse sine and typed in decimal 9607, I could put the 0 in front, but it's not necessary. I'll still get the same answer typing it in. But again, your choice. Now, just then we explained, and I explained again. Here we go. We add sugar to coffee. Sine is positive in quadrant 1 and quadrant 2. So this answer of 74 is in quadrant 1. So the same reference angle is in quadrant 2. So in quadrant 2, it's 180 minus the 74, which is a 106. So again, I'm asking you for two possible angles. And remember, you're dealing with a triangle. So you're dealing with a 74 or 106. So if you put 106 in here and worked it out, you would come up with 26.9. If you put 74 in here and worked it out, you would come up with 26.9 as the area. So either one of these will do, because the 74 is an acute angle in the first triangle. Reference angle is 74. So this rotation here is 180. Take away 74. So that's a 106. Whereas this rotation here in the first quadrant is just 74. So that explains using the two sides and included angle to find the area of a triangle. Or you get the area of a triangle with the base times the height if you have it. So, hopefully you enjoyed my video. If you did, click the like button, click the subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.